Hello, I am Professor N.B. Hulle from G.H. Raisoni Institute of Engineering and Technology, and in this video we will try to understand the basics about superposition theorem. First, we will go through the statement and then we will see one small example, and then we will look at the explanation part of the superposition theorem, and if the time permits we will go through some of the problems based on the superposition theorem. As far as the statement is concerned, the statement of the superposition theorem states that for linear bilateral active network consisting of two or more than two sources, the superposition theorem is applicable to the linear network. It must be bilateral, it must be active, consisting of two or more than two sources. Minimum requirement is two sources. Current flowing through the load resistance is algebraic summation of the currents when each source considered acting alone in the circuit, and by that time remaining all sources in the circuit are replaced by the respective internal resistance. The internal resistance. This is the statement of the superposition theorem. First we will carry out one small assignment which I have considered here, and then we will try to understand how to go for the explanation of the superposition theorem. Now, what do you mean by the superposition theorem? Now, here as per the statement, if we are interested to calculate current in the load resistance, which is RL is equal to 5 ohm in this particular case, this is the load resistance. What the statement says? Algebraic summation of the currents. What do you mean by the algebraic summation? Summation with sign or summation with polarities. When each source considered acting alone in the circuit. Means at a time we are going to consider the single source and we will calculate the current in the load resistance for that particular single source with direction or with sign or with polarity. That is nothing but the algebraic summation. Means here if we have the two sources, we have to calculate current two times. Initially for the source 1 through the resistance R1, RL, and for the source V2 through the resistor RL, and then we will find out the algebraic summation depending on the polarity, depending on the direction of the current, and then that is nothing but the superposition theorem. Now here in this case I will consider its first case, that is case 1. In first case we will consider the 15 volt source. By that time we will remove or replace the second source, which is 10 volt source, by the internal resistance to apply the superposition principle. Now here in this case, if we are considering the first source and we are replacing the second source by internal resistance, and internal resistance of the ideal voltage source is 0 ohm. That's why it is replaced by the 0 ohm, or which is nothing but the short circuit. This is 5 ohm. It is 15 volt plus and minus. We will try to find out the current in this particular loop, and which is forward for the 5 ohm resistance, and this current I will name it as I1 for the case number 1. This I1 is equal to total voltage, which is 15, divided by total resistance, which is 5, which is 3 amperes. This 3 amperes is the current flowing in the 5 ohm resistance, and its direction is the forward. Its direction is forward. Similarly, we will consider the case number 2. We will consider the case number 2. And in the second case, we will consider second source. By that time, we will replace first source by its internal resistance. Now here in this case, in the second case, we are replacing this first source by its internal resistance because we are interested to calculate the current in the load resistance by considering each source at a time. Now here in this case, if its voltage is the 10 volt, its resistance is the 5 ohm, and in the second case we will find out the current. Here in this case, this current I will name it as I2. This will be the plus and this is minus. Here in this case we can calculate its actual direction of the current because at a time we have the single source every time in case of the superposition theorem. Now here if we are calculating its current I2, which is equal to total voltage divided by its total resistance, which is 5. Here it is 10 divided by 5 is nothing but 2 amperes. Now look at the direction in the load resistance. Direction in the load resistance is backward. It is reverse as that of the original direction. Now here comes the statement of superposition principle. What the superposition theorem says: current flowing through the load resistance is algebraic summation of the currents when each source considered acting alone in the circuit. Now here in the case 1 we have considered I1 15 volt source and we have calculated its current I1, which is forward, and I am assuming this current as a positive. That's why I1 is a positive. And here similarly algebraic summation means summation with polarity. Means here current in the 5 ohm resistance, it is due to this current, this source, current due to this source, and current due to the 10 volt source. Now current due to first source is I1, which is positive, and the current due to the second source, it is opposite to that of the first current direction. That's why I will take it as negative, which is minus I2, which is equal to, here in this case, which is equal to, here in this case, this current is equal to, now here the first case is a 3 minus 2, which is equal to plus 1 ampere. That is nothing but resultant direction is a forward. This is the way to deal with the superposition principle. Now here, if we have understood the superposition principle, means at a time we have to consider only single. So there are so many methods for calculation of the current in the particular branch by using the superposition principle, maybe the reduction technique or maybe the KVL, KCL, and so many things are there. I will go through the explanation part first. Now here in this given figure, we have the two sources, source V1 and source V2. And here in this case, we will assume this R3 as RL. Means in this resistance RL, we are planning to calculate the current, and we will see the general explanation for this superposition principle. Now here in this case, again, if we are considering the case number 1, in the first case, we are considering the first source, which is V1, and V2 is replaced by its internal resistance. Then its figure will be something like this. Now here in this case, we will consider the first source. Second source is the voltage source. Then it is replaced by its internal resistance, and internal resistance of the ideal source is 0. That's why it will be R2, this is R3, here it is R1, this value is the V1. Now we will reduce this figure into the single loop, we will calculate its current, and then we will see about the other things. Now here in this case, if we are simplifying this figure further, it will be something like this. Here it is, this is Rp, which is equal to R2 into R3 divided by, it is R2 plus R3. Here it is R1. This source is V1. It is plus and minus. Now here we are able to calculate the total current in this case, which is I1. This I1 is equal to, what is the total current I1? Now here this total current I1 is equal to total voltage, which is V1, divided by total resistance, which is R1 plus Rp. Now here we know the total current I1. Means what current we have calculated? We have calculated current, this current I1, current from the source. But we are interested in this current in the load resistance. I will call it as IL1. Now we are interested in the current IL1 for the first case, which is equal to IL1, which is equal to. Now here in this case, this IL1 is equal to, we will use the current division rule. That is total current, which is I1, into resistance of the opposite branch. This current is known, We are interested to calculate IL1. This opposite branch is the R2 divided by resistance of both branches, that is R3 plus R2 or RL plus R3, because R3 and RL are the same. Now look at the direction of the current. The direction of the current is downward. That is IL1 is downward. Similarly, if we are applying this method for the case number 2, now here in the case 2, what we will do? In the case 2, we will consider the second source. Here is the case 2. And we will replace the first source by its internal resistance. This figure will be something like this. This will be the figure. This is R3 is equal to RL, and here it will be the value of the source, which is V2. Something like this. It is something like this. Here it is R2. This is R1 again. Now here we will reduce this particular loop, something like this again. This is parallel. These two branches are in the parallel combination. That's why the figure will be something like this. Here, this is V2. Here is R2. And this will be the RP2, which is R1 into R3 divided by, it is R1 plus R3. Now here in this case, this is the direction of the current. I will call it as I2. This total current I2 is equal to total voltage, which is V2, divided by total resistance, which is R2 plus RP2. We know this current. Where is the current is known? Current is known from the supply, something like this. This current is known, which is I2 from the source. We are interested in this current. I will call it as IL2. This IL2 in this case is equal to total current, which is I2 here. This total current I2 into resistance of the opposite branch. This current is known. We are interested to calculate current in this branch, as this will be the opposite branch, which is R1, divided by resistance of the both branches, that is R1 plus R3 or Rn plus RL. Again, in this case, its direction is downward. Now here, look at first current is the downward, second current is also downward. That's why the direction of current in both cases is the same. That's why what the superposition principle says. This total current is equal to, or resultant current according to the superposition theorem, is equal to current in the load resistance for the first source plus current in the load resistance for second source, that is IL2. This IL1 plus IL2 is the current flowing through the load resistance, which is nothing but the superposition principle. Here in this case, this sign is a plus because the direction of current in both cases is the same. That's all for this particular concept as far as the superposition principle is concerned. In the next video, we will try to understand the sums, or we will try to solve the problems based on superposition theorem. Thank you.